Hi, folks. Welcome back to the PagerDuty Twitch channel. I am Mandy Walls, a DevOps advocate here at PagerDuty. Today, we have for you Frank Emery from our product team. And Frank is going to tell us all about event orchestration. Welcome to the channel, Frank.
Thanks for having me. I'm excited to be here.
Yeah. So tell us about yourself before you jump into what you're going to tell us about.
Yeah, my name's Frank. I'm a senior product manager here on the event intelligence team, and specifically, I work with our event automation products. Really fun space. We obviously get a tremendous amount of data here at PagerDuty, and my job is to kind of figure out how do we use that data to do something more than just notify people. Hopefully, notify them less. Hopefully, help them get their jobs done a little bit easier. That's really exciting. And before this, I worked in the AI space, and my background's actually in mathematics from way back in the day. So I promise the second half of this talk will have a little bit of fun math stuff built in.
We are here for all the nerdiness. Excellent. So we'll get started. If you have any questions along the way for anyone out there, you can just add them in the chat, and we'll answer whatever you've got going on or anything you'd like to know from Frank. So yeah, so take it away, man.
Awesome. So I will go ahead and share my screen, and we can jump into it. As Mandy mentioned, today we're talking about event orchestration. And more specifically, in this kind of second half, all the fun stuff you can do with rule nesting. So I know with this project, I learned a lot about, what rules do, what nesting does, all the different data structures that work with those. And so it's going to be really exciting to walk everyone through that as well. And so we kind of did the intro already, but this is me. I told everyone who I was, so I'll kind of skip that. And we'll just jump right in. And sort of the first place that I always like to start when we're sort of talking about event automation and event intelligence and what PagerDuty is doing is sort of with this slide, because it kind of paints a really good picture of everything that PagerDuty works on, and sort of how complex that environment is, but also all of the stuff that we can do for our customers. And I'll kind of work my way around counterclockwise here, but it all really starts with human mobilization. So this is what people are pretty used to, and this is basically PagerDuty reaching out, your all responders, letting you know in the middle of the night that something's down and helping you get it back online. And then below that, we have automation. So this is where Rundeck comes in, and really these features are designed to help people solve issues faster. So automating diagnostics, automating resolution. Then on the far left-hand side there is what sort of I work on, department I'm in, and that's event intelligence. And this set of features is designed to take all of like the tremendous volume of events coming into your system, and like there's more every day, there's tremendous amounts, and doing two things with them. And the first is helping people figure out what's wrong a little bit faster than they typically would. And I'll kind of get into that problem a little bit more in a couple of slides. But then also, like, we're getting all of this amazing event data coming in, using that data to be a bit more clever, helping you automate things and helping hopefully get work off your plate so you can get back to all the fun development work that you want to do. And so this is kind of what PagerDuty works on. This is where event orchestration lives, sort of like right down in here in this corner, and sort of what event intelligence is designed to solve. And this is really important for PagerDuty and for our users too, because there's a lot of event data out there. It's getting worse. We saw a 70% growth rate in event volume, which is kind of shocking because there was already a lot of event volume. And this is being driven a lot by, I don't want to say sort of a cliche line, but everyone's working from home. There's more systems. People are getting a lot more advanced with the monitoring they're doing. They want to get ahead of incidents. And that means, taking a look at your data more often. That's going to generate more events. And that's kind of a blessing and a curse. On the one hand, you get a lot more data, but on the other hand, you get a couple of problems that come out of all of that data that aren't so great, but that event intelligence can really help you out with. And that event orchestration is designed to start really addressing and utilizing. And so the first big problem that we see coming out of all of this event data is, obviously teams get, destroyed with noise. I've been on incident calls where they had to call on a second responder to just acknowledge notifications because the first responder was busy fixing problems and the second responder had to actually say, hey, let's fix these things. So that's sort of like the first big issue that comes in, and that's sort of what event intelligence has been known for historically is, helping teams get their noise under control. The second thing that event intelligence really helps people deal with, and again, this comes up a lot with the event volume, is folks are confused about where and what's going on. So, when you're getting, all of these events coming in, it's sometimes hard to parse the signal from the noise and figure out exactly what the issue is. When you compound that with the fact that you could have, 10, 20, 100 people on an incident response call, it can get kind of confusing about where the root cause is and how to address things. And this is another big area that event intelligence is designed to solve. And then finally, and this is where event orchestration comes in now, is there's so much time wasted doing manual tasks. And you know, like I know my team, they have outages occasionally, and I'll look at the thread as well. And you know, so often an incident will come in and like you do the same 5 things, like every single time, the same 5 things over and over and over again. And what we look at there is it's like if you're doing the exact same thing every single time, and you know exactly when to do it and why to do it and what the output's going to be, why are you doing that? Like, why are you logging in to PagerDuty and like pressing those buttons? That should be all automated. We should be giving people back that time. And it's like not a small amount of time that we're talking about here. So when we were looking at event orchestration, like to start, we wanted to say, how do we start solving wasted manual time? We thought it was a big problem. It turns out it's a huge problem. So 20% of incidents are actually being resolved in 5 minutes or less. And like these aren't auto-resolving incidents. These are like someone logged into PagerDuty and they saw the incident, and then 5 minutes later they resolved it. And one of the things we told ourselves on the team was, you know, nothing takes 5 minutes or less to solve. Like if you're logging into PagerDuty and you see something and you're solving it in 5 minutes, you kind of know exactly what you have to do. So that's a really well understood resolution process. And if you understand that resolution process that well, then like, why are you doing it? That should be automated. That should be something we take off your plate and we handle. And you know, these stats get even crazier. Like when you crank this up to say 30 minutes or less, which in my opinion is still a fairly well understood problem, you know, that percentage skyrockets, right? And so we can kind of see there's tons and tons of incidents coming in. There's more and more event volume. People are solving these things really quickly because they understand the problems. So why don't we give them the tools to just deal with that? And that's where event orchestration comes in. And so with event orchestration, what we built is a fairly complex decision engine that lives directly within your event ingestion pipeline. And so what's kind of nice about this is because this decision engine lives directly in your pipeline, that means it can analyze, determine logic for, and then automatically act on events as they're coming into PagerDuty in real time. So like microseconds, it's analyzing all of these things, it's deciding what to do, and then it's sending the events on their way. And what that allows us to do is kind of take all of the events coming from our 600 integrations, and then apply all of this logic and automation to figure out like, hey, we got this event, you know, it's one of your 1 million events this week. What exactly should we be doing with it? What's the next best action to take? And the nice thing is with a lot of our automation, I'll kind of show you this in a second, you know, because we're able to nest all this automation together, you can have one automated action, sort of start your diagnostic process, learn more about the event, and then subsequently, you know, use that information it learned to figure out what to do next. And so what that allows you to do is take what are a lot of human processes that we're all sort of used to doing, just, you know, intrinsically, like you look at a problem, you read what's in the event payload, you know what to do next. You can start to automate all of that out. The more you understand a situation, the more you understand an event, the better you're able to automate that. And so, you know, the output of this is your events get ingested, logic processes them, and then you either have, you know, a really high quality incident where the responder who's getting it knows exactly what to do and where to start, or ideally, you don't get an incident at all. It just gets fixed, gets solved right away. By the time you get to your computer, you know, that event has turned from a triggering event to a resolve event, and you can just go back to sleep, ideally, if you can get back to sleep really quickly. And so that's kind of what we did with event orchestration. And the way we did that was we built in 3 features. And the last of these 3 features is going to be what the tail end of this talk is going to be about. And the first one is, you know, we really beefed up our conditions. So for folks who used PagerDuty in the past, event rules in the past, or who have used other sort of event management solutions, you know, rule bloat is a thing. It's a painful thing. It can crash your browser when you load 50,000 rules to do one simple task. And so PagerDuty built their own condition language called the PagerDuty condition language, pronounced pickle. And what pickle lets you do is it actually lets you compress all of your rules substantially. So our EA testers seeing a 90% compression rate for their rules. So what used to take them 10 rules to solve is taking them 1 rule to solve. And it's because what we were able to do is with pickle, we were actually able to go in and define a bunch of custom functions. We were able to add support for nesting and brackets and all of this PagerDuty specific stuff that comes with rule definition. And we just built that directly into the rule engine that we have. The next thing we did is we built contextual rules. So, one of the things that we hear come up a lot is, I wish I knew more about the state of my system, or, if I had access to this sort of data on how events are being processed, or the volumes, I would know a lot more about what the problem's having. And one of the great use cases that I heard during the EA testing was someone said that every day they have an incident come in, and if they see one of those incidents, it's problem A. And if they see between 1 and 20 incidents, then there's nothing wrong with their system at all. But if they see more than 20 incidents, that means they're having a catastrophic outage. And to write automation that knows how to parse that kind of complex situation out, you really need to understand the context for a service, the rates of events going in, and what that rate tells you about the kinds of processes and the kind of issues that your teams are having. And so we built all that in there. So you can actually write some pretty complex context-based rule now. And then finally, what we did was we allowed you to nest rules. So with rule nesting, what you can do now is you can write a rule, you can fill it with automation that tells you information about this rule, that can populate variables, that can change or kick off automated scripts. And then afterwards, you can actually write another rule afterwards that inherits everything you just did. All the variables you made, all the automations you kicked off, all of that stuff persists, and you can just keep on doing that over and over and over again. And when you start nesting rules like this, it actually results in some fairly, I think, interesting, mathematical outcomes. And so what I'm going to do is go to the next slide and kind of walk you through a little bit more. And we're going to start, this is where the math comes in. We're going to start by talking about directed acyclic graphs. So when we talk about rule nesting and event orchestration, sort of at the face value, what we've done is we've built a more powerful rule engine for users. We've given you the ability to nest rules. We've given you better conditions. It looks much nicer than it used to. Behind the scenes, what we've done is we've allowed users to actually start building these what are called directed acyclic graphs within their event ingestion pipelines. And when you have graphs like this that exist, where you're dealing with a stateful message throughout the entire flow, what you're really building is a finite state machine, which is great and has a couple of really useful properties. And what these finite state machines are doing is they're basically saying an event is coming in. We know the statefulness of that event, and we have all the data associated with that. And we're going to now push it through this graph, and we're going to pick apart that data, and we're going to see what that turns this event into on the other side in a highly deterministic fashion. So to kind of help out, basically what a finite state machine is, it's like a vending machine. So if you walk up to a vending machine, you put $1 in, you press Coke, and you kind of expect a can of Coke to come out. And that's because vending machines are highly deterministic finite state machines. If you walked up to a vending machine, you put $1 and you press Coke, you got a banana out the other side, that would be unfortunate. It's kind of not what you wanted. Bananas are delicious, they're good for you, not really what you wanted. With event orchestration, we've replicated that process. And so with this, what you can do is you can use these directed acyclic graphs to push an event in on one side. In this case, event is $1 you're putting into the vending machine. It's going to follow all of these rules, all these processes, all this logic you've put in. And with 100% certainty, on the other side, if you put in $1 and you press Coke, you're going to get Coke on the other side. In this case, what you're actually getting is, either an automated remediation or a suppression event or an enriched event. And that determinism gives you incredibly precise control over exactly what happens to your events as they're being ingested. So there's no guesswork here. You go into event orchestration, you look at the rules are written down, and you can know with 100% certainty when an event comes in exactly what's going to happen to it, and you can control that along the entire way. And that allows really low risk, really precise deployment of automation. So when we talk to users and we say, why don't you start automating all of your incident resolution? Why don't you, just automatically restart Elasticsearch? You kind of know you have to do it. Why don't you just do it? And the answer we get back a lot is, well, I'm scared. I don't want to do that, right? I don't want to just have the machine take over because I don't know what's going to happen. I don't know if it's going to restart Elasticsearch twice or 0 times, and I kind of want to be involved. And what event orchestration does is it gives users that ability to have that precision that gives them the comfort to start trying out those automation use cases because there's no guesswork. You know exactly what's going to happen. You know exactly what sort of automated remediation is going to be applied to the events with absolute certainty. So that's kind of fun. I think that's fun. That's kind of the behind the scenes about what really event orchestration is doing and sort of the math behind how it works. And sort of another way to look at this and how we describe things is when we look at these directed acyclic graphs that event orchestration is, we look at them across 2 dimensions. And so the first dimension is what we call density or graph density. And what this means is when you're building an event orchestration and you have a rule set, how many rules are in that rule set? Is it like 1? Is it 4? Like in this case, is it 100? The more rules you have in a rule set, the denser that rule set is. And this is a really important dimension for us to talk about when we look at event orchestration, we talk to users. Because what density is highly correlated with is the number of different sort of known states within a system. So if you have a really, really dense rule set, it means you have a bunch of distinct, unique, separate use cases that you have a really good idea about. You have all the information you need to define them all at the time, and you kind of know exactly what to do in each case. So density is a great indicator of a team that, has a good understanding of their system and the noise generated within it. Especially if you have a really dense graph with not a whole lot of nesting. It usually means you're here to either suppress noise in your system or you're here to enrich data in your system. And because you have such a good idea of how your system operates, you're actually able to write out each of the rules individually. And sort of another way to look at this is density occurs when you have all the information you need and you just need to use it. The flip side of this, the other dimension we look at, is called depth or graph depth. And what graph depth is the number of rules you have one after the other. And this is kind of where things get fun. I think they're fun from like a set theory perspective. When you look at density, as I mentioned, you're looking at known information. So you have an event, you have 10 pieces of data with it. You're going to use those 10 pieces of data to accomplish some goal. When you look at depth, you're actually doing something completely different. You're basically creating new information. So each time you nest a rule inside itself, you're adding one of 2 pieces of information to that rule. And that information you're adding is going to give you the precision that you need to figure out what sort of automations to run. And so when we look at sort of high risk automation or what people perceive as high risk automation, so like restart production or rollback, usually they need a lot of information and a lot of data and context to be comfortable kicking those off. And rule depth, that layer of nesting, is typically what gives people the comfort and the precision to do that. And so, if density is highly associated with noise reduction and event processing, rule depth here, or graph depth, is highly correlated with automation. Typically people who are nesting many, many rules one after the other are trying to get the information they need in order to kick off an automation, restart their system, and be comfortable with the end results. And sort of to double click on that a little bit, because I mentioned before that density, you're using the information you have, depth, it's all about precision. What you're actually doing when you have a deep rule or a deep rule set, and you're nesting things together, is you're actually creating brand new data points. So an event comes in, you have 10 pieces of data associated with it. As soon as you nest one rule after the other, the second an event makes it to that next rule that's nested beneath it, now you have 11 pieces of data associated with your event. And so what you're doing is each layer of nesting is you're actually adding information to your set of information for an events. And that additional information that gets created is typically what you need in order to ensure an event is going to be treated the way it needs to be treated. And the example I have here is like a really basic example of this. We sort of have an event comes in. That first rule is basically saying, hey, kick off an automation. This is an Elasticsearch event. Go restart Elasticsearch. Move on with your life. But there's a lot of risk with that because, what happens if 2 events come in? You don't want to restart Elasticsearch twice. You're going to make a bad problem worse. Well, so how do you solve that problem? To solve that problem, you kind of need to understand a little bit about your system. You need one more piece of data, and that additional piece of data is, is Elasticsearch already being restarted? But you're not going to get from a monitoring tool an event comes in that says, hey, Elasticsearch is down. Here's a summary, here's the cluster, and also I'm already being restarted. You're not going to get that because Elasticsearch is being restarted. This is not data that existed in the universe yet. But that nested rule that I have there, this little fellow there on the end, what that does is it actually says, hey, you've decided to kick off an automation. Great. But if you already see one event existing for this service, you already see one event being processed by this automation, suspend everything else. Stop all automation, stop all notifications for 15 minutes, give Elasticsearch time to come back on. And now what you're doing is with this event, you've added that additional data point to your information space that you didn't have before. So you don't have to wait for a monitoring tool to tell you Elasticsearch being restarted or to start populating events with that. You're basically populating events with this information based on your human intuition. You've coded in logic where once executed, that logic now bakes additional data into your information space that you can use for further events and further automations. And you keep nesting these over and over and over again. And each time you do, you're adding more information to that space of event data that you have. And to kind of like bring it down, there's really two kinds of information that get added today with event orchestration. I say today because event orchestration it's a platform really that we can build upon. We can add more stuff to it downstream. But the two pieces of data we're adding today is one, you can create custom variables that persist with an event. So an event comes in, it's missing, some context about a possible root cause. You can actually populate that in the event with one of these nested rules. You can explicitly say, hey, based on my past knowledge, I know, even though this event doesn't say it, this is what the root cause is going to be. And then you can use that root cause information downstream for the rules. That's kind of the first piece of information you can add. The second is context. And that's what you see here with this sort of threshold rule in the end, is you can start to add information about system context. So is my system already having trouble? Is it in a bad state? And then bake that into your event to have that influence further event processing. So it's kind of the two big things you can add there. And again, now that we have this nesting in place, we can kind of start to explore other types of information we want to add that can help teams be even more precise. So kind of bring it all together, you end up with, and that's smaller on my screen than I expected, you end up with a bunch of different tools that you can combine to solve a bunch of different unique use cases. And so, here we have a fairly simple graph. There are about 4 rule sets in play. But with these 4 rule sets, a team can make sure they no longer get notifications outside their time zone. You're asleep. You don't want to wake up for a P2. That's no longer going to happen. You can also automate diagnostics for flagging alerts that didn't self-resolve. So you know that alerts of these nature should self-resolve in 5 minutes, but if they don't, kick off diagnostics, kick off automation so that when the engineers do get called in, they A, know it's not a flagging alert, it's a real problem. B, they have the tools to start addressing it. The subsequent rule set, you're able to automatically identify noisy parts of your infrastructure and automatically silence them, stopping teams from being distracted. And then finally, kick off root cause information. So you're able to say, based on the logic that these events have followed, I know exactly what this problem is going to be. I'm just going to tell people. So when this event turns into an incident, there's a note on the page saying, hey, Carl, here's exactly what happened. Here's exactly how to solve it. Don't bother looking anywhere else. Here's the exact thing to do. And so what it really does is it helps teams, going back to the original part, get rid of all that manual work around handling incidents, whether it be dealing with these known issues or helping responders just get to work faster. So they don't have to do the manual work of digging around GitHub and pulling up change requests. They can just start addressing problems right away. And so with that, I'll kind of kick it over to questions. I haven't looked at the question screen yet.
Yeah, we've got one so far in the chat. So if you have any questions, go ahead and add them in the chat there. From KPOW58, they'd like to know, so rule sets have been able to send custom actions. Can we still do that with event orchestration?
Yes, you can actually not only send custom actions, but we've improved event orchestration so that you can also add a near unlimited amount of both JSON body and custom header fields. So what you can do is you can kick off custom actions securely now. So you can add in those custom headers, put any of the secure credentials that you need into those, and be able to sort of more effectively kick off automations in your system. So one of the fun use cases that I've done is like actually use event orchestration to open up a Zoom room for myself, which was really fun. I had a blast with that. And so you can do all of that fun stuff now with event orchestration.
What's the so since we also have an automation platform in Rundeck, is that really meant to be maybe an initial or easy target for some of these automation steps for folks?
Yeah, well, and it's good you mentioned that. So one of the things that we're going to be releasing in the next couple of months as well, now that event orchestration is out, is actually the ability to integrate with Rundeck directly. So in a lot of the examples I showed today, we're using webhooks, but what's going to happen as well is you'll be able to add to any of these rules a Rundeck action specifically. So if you want to take, a more complex automated action than just a webhook, you can go in there and you can specify a run deck action specifically, and then that'll kick off an even more complex workflow that can do a lot more within your system. That can really start addressing more complex issues that you might have encountered in the past.
Awesome. That'll be great. Looking forward to that one. So another question in the chat, are there any tools that could help convert existing rule sets to event orchestration based rule sets?
Yes, so it's a great question. For any of the math nerds in the audience, what that's called in a case like this, when you're dealing with a directed acyclic graph, is what's called transitive reduction. And so what we're working on now is sort of a way to take all of your rules that exist and replicate their outcome from an automation perspective within a graph structure, like what we have. So we're basically taking, a series of connected lists of automated actions, and we're saying, how do you construct a graph out of these? So it's a fairly complex mathematical process, but it's something we're actually working on right now because we want to make sure that folks can start to take advantage of this as easily as possible. So
Yeah.
not out today, but in the very near future.
Awesome. Yeah. So for folks who are just getting started with this, like I know you mentioned at the beginning that there were like 20% of events are solved in the first 5 minutes. For teams that are looking to get started with event orchestrations, is that a good place for them to target sort of their first foray, is to look at those things that they're solving that quickly and just put them into this solution?
I'd even make it simpler than that. I think the best way to start with event orchestration is, our users know their systems the best. Like, they maintain them every day. If you know that there's a couple of really well understood problems that like keep coming up, they bother you a lot. Whenever these incidents happen, you're like, oh damn, it's this. I'll go like deal with this, folks. We've dealt with it a million times. Those are the use cases I would start with. I'll say, like, we stress tested event orchestration against 52 of our biggest customers during the EA. I challenge people to find a use case that we can't support. We haven't found one yet. And so find those processes on your team that are really distracting you, that you understand really well, and code those into event orchestration. Build that logic in so that you don't have to start doing it again. And, that could be an incident that takes 5 minutes to solve or an hour to solve. But if it's really well understood, you know exactly what to do, it should be able to automate it.
Cool. Now, do these require any kind of special permissions right now, or subscription levels? What can folks expect to see when they go into their accounts?
So from a permission standpoint, nothing too fancy. It's the same as what we use for event rules today.
Great.
So, the action-oriented rules are restricted to team level access. So they're associated with the service. If you have team level access for your service, you have access to those. Similarly, the routing logic is available to teams as well, or to admins. So that's kind of the permission side. From a packaging standpoint, the functionality is kind of split between event intelligence and sort of our basic packages. So the way we've kind of structured it is functionality required to do basic event processing. So basically one level of nesting that's included in all of our tiers. When you look at multi-tier nesting, and when you look at automation, that's the stuff that's currently part of event intelligence.
Okay. Was there anything in the early access customers that you thought was like absolutely amazing that you can give folks some ideas on?
The one that was really cool for me is actually the example I used here, where you can create nesting to basically control whether or not you over automate. I will say one of our EA participants was very creative, and they figured that out, where you can use nesting to infer whether or not your system's being restarted to not kick off new automations. That was the really cool one. The other one that was kind of interesting is the other example I used, where, based on the number of events that have been detected, it's a completely different root cause analysis process.
Yeah.
That one was very interesting.
Craziness. You just have no idea what kind of quirky things happen in distributed systems. They could
it's true. People get into crazy situations because, every product's unique, and when you have unique problems, you're going to have, interesting use cases.
All kinds of interesting things. One more question from the chat. If you trigger automation to try and auto-resolve an issue, how do you validate the automation worked correctly within the event orchestration? Are you getting feedback, or are you just waiting for that webhook to return?
That's a very good question. So today, with the GA that just went out on Monday, we don't have a feedback process yet. but that is something we're actively working on for this year. So
Cool.
now that event orchestration is out, we can start to do some research, and we're looking at building in that feedback mechanism in this fiscal year.
Awesome. So you have another event coming up.
Yep.
You have a webinar, and I'll put the link up for folks if you'd like to attend. Can you tell us a little bit about that and what you're going to talk about there?
Yeah, awesome. Yeah, so the webinar, that's sort of our big launch webinar. We're going to be talking about sort of event orchestration. We'll be doing a demo of the product as well, and we'll just be going into a bit more detail on, what is the product, what are the use cases, specific examples, and then I'll be doing a live demo portion where I'll kind of go in and actually start creating some of these rules and walking people through that process.
That will be awesome. I think I am going to make some time in my calendar to go to that. So that's going to be on the 15th of February for folks. If you'd like to check that out, I'll also put the link in the comments here so you can just click on that. And yeah, is there anything else you'd like folks to know about the product before we sign off?
No, I mean, I'm just excited to hear feedback from people. So, take a shot. Let me know if you've thought of some crazy use cases that you've automated. I'm always excited to hear about those. But yeah, feedback is a gift. I'm looking forward to hearing from people and seeing what they come up with.
Yeah, and I would love to see it too. So we've got plenty of space on the channel on here on Twitch. If folks would like to come on and show us the things that they're automating, I'd love to see it too. We would really get a kick out of seeing everything that you're doing and what you're solving and how you're solving it with these
Absolutely.
products. So we would love to see it. So Frank, thank you so much for coming on.
Thank you.
So, excellent. Everybody, thank you so much for joining us. If this is your first time joining us here on Twitch, make sure you follow our channel so you don't miss any of our shows. We're here regularly on Mondays and Fridays with PagerDuty Garage, which is the show about the PagerDuty API. And we feature products and product features and partners on here regularly too. So make sure you're following us. In the meantime, thanks for coming. This has been great. And yeah, if you want to get in touch with the community team, if you'd like to be on our channel, if you've got anything interesting you're doing for PagerDuty, give us a shout. We're community-team@pagerduty.com. In the meantime, we'll wish you an uneventful day.
There you go.
All right. Thanks, Frank.
Thank you.
Bye. Thanks for watching. Make sure you never miss a stream. Follow us at PD Community and PagerDuty on twitch.tv. If you're watching on YouTube, don't forget to like and subscribe. If you'd like to be on our stream, email us at community-team@pagerduty.com so we can feature the cool things you're doing. And don't forget, check out all of our global events on our calendar at pagerduty.com/events.